Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 30, Organic Chemistry 2. Today we will continue on chapter 7, Carboxylic Acid. In the previous lecture, we covered the following topics, naming the carboxylic acid structure and physical properties, acidic and basic character of carboxylic acid. Today, we will talk about preparation of carboxylic acid. Commercial process. The first commercial is fermentation of sugars. Acetic acid, vinegar for food is produced by fermentation of sugars and starch. An intermediate in this fermentation is ethyl alcohol. When alcoholic beverages such as wine and cider are exposed to air, the alcohol oxidizes to acetic acid. This is the source of wine vinegar and cider vinegar. Method 2, acetaldehyde oxidation process. Some industrial acetic acid is produced from ethylene using oxygen, palladium chloride, copper 2 chloride catalyst to form acetaldehyde, followed by another catalytic oxidation using oxygen cobalt-based catalyst at 55 bar pressure and 150 degrees Celsius temperature to prepare acetic acid. Method 3, methanol carbonylation process. Methanol can also serve as feedstock for an industrial synthesis of acetic acid. The rhodium catalyst, the reaction of methanol with carbon monoxide at 150 to 100 degrees Celsius and 30 to 50 bar pressure to produce acetic acid in 95% selectivity and 5 side products such as formic acid and formaldehyde. Hydrocarbon oxidation process. Hydrocarbons derived from petroleum stocks such as butane and naphtha are utilized to generate acetic acid using cobalt acetate and chromium acetate catalyst. The reaction proceeds at a comparatively higher temperature, 150 to 230, and pressure 50 to 60 bar. That's butane, oxygen in presence of cobalt-based catalyst, 50% acetic acid. Benzoic acid can be produced by the oxidation of toluene with potassium permanganate, nitric acid, or other strong oxidant. Toluene, nitric acid, benzoic acid as a product. Two important commercial dye acids are adipic hexadioic acid and terphthallic acid, benzene 1,4-dicarboxylic acid. Adipic acid is used in making nylon 66, and terphthallic acid is used to make polyester. Benzene reduction with hydrogen nickel at high pressure provides cyclohexane, which upon oxidation in oxygen cobalt 3 acetate in acetic acid provide adipic acid. Terphthallic acid from paraxylene, again oxidation, cobalt molybdenum based catalyst provides terphthallic acid. Hydrolysis of triglycerides obtained from plant or animal oil. This method of synthesizing some long-chain carboxylic acid are related to soap making process and called saponification. So fats or oil hydrolysis in base generates glycerol and long-chain fatty acid salt from C6 to C18 saturated and some of them unsaturated. Synthesis of carboxylic acids, oxidation of primary alcohols. Chromic acid or sodium hypochlorite oxidizes primary alcohol to carboxylic acid via aldehyde intermediate. Oxidative cleavage of alkene and alkyne. Cold dilute potassium permanganate reacts with alkene to give glycol. On the other hand, warm concentrated potassium permanganate solution oxidizes the glycols further, cleaving the central carbon-carbon bond. So alkene double bond with warm potassium permanganate furnish the carboxylic acid or ketone, depends on what type of carbon. The carbon has no hydrogen will be ketone. The carbon carrying one hydrogen will be carboxylic acid. With alkynes, either ozonolysis or a vigorous permanganate oxidation cleaves the triple bond to give carboxylic acid. Triple bond with conc potassium permanganate or ozonolysis followed by hydrolysis provide the carboxylic acid via 1,2-dicarbonyl intermediate. Oxidation of arene side-chain. Side-chain of alkyl benzene are oxidized to benzoic acid derivatives by treatment with hot potassium permanganate or hot chromic acid. So alkyl will be long chain or branched with at least one benzylic hydrogen, treat with potassium dichromate sulfuric or potassium permanganate, provide the carboxylic acid, benzene carboxylic acid, benzoic acid derivatives. Carboxylation of Grignard, alkyl halide with magnesium in ether provides the Grignard reagent, which upon treatment with dry carbon dioxide provides the salt, which upon hydrolysis furnishes the carboxylic acid. Hydrolysis of nitrile. Again, alkyl halides with potassium cyanide in acetone provides nitriles. The nitrile on acid hydrolysis or base hydrolysis furnishes the carboxylic acids. Show how you would accomplish the following multi-step synthesis. You may use any additional reagents and solvent you need. Starting from 2-phenyl ethane 1-ol to transfer it to 3-phenyl propanoic acid. Here we have phenyl and 3 carbon in the propanoic acid. And in the starting, we have only 2 carbon side chain here. So we have to add 1. How we can add carbon? In this case, we can add carbon from the cyanide, or we can add it by CO2. So the retroanalysis, 3 carbons here, COOH, we will do the same, but we have CN. CN is a good nucleophile, so we can get it from the 2 carbon autosyl and of course cyanide as a nucleophile. We can get autosyl from alcohol. So starting with 2-phenyl ethane 1-ol with tosyl chloride in pyridine, we get the autosyl. React this compound with potassium cyanide will give the nitrile. Hydrolysis of the nitrile with acid, aqueous acid, and heat will furnish the target molecule 3-phenyl propanoic acid. How we can transfer from methylene cyclohexane to 1-methyl cyclohexane carboxylic acid? Well, retroanalysis once again, this is an extra carbon. We can get this from the reaction of Grignard reagent with CO2. We can get Grignard from bromine. We can get this bromo compound from starting material methylene cyclohexane. We add HBr. This is Markovnikov. The hydrogen will go to the carbon carrying more hydrogen, CH3, and the Br will go to the less. Okay, so here we have Br, HBr added as Markovnikov. Reacting with bromo compound with magnesium in ether will provide the Grignard reagent. Add CO2 dry carbon dioxide to the reaction mixture will provide this salt. Hydrolysis of the salt will furnish the target molecule. How we can transfer methylene cyclohexane to 2-cyclohexyl acetic acid? Well, we can do again. This will come from Grignard reagent with CO2. And the Grignard from the bromo compound. And this bromo compound, we can get it again from methylene cyclohexane, but by the addition of HBr anti-Markovnikov. So if we started with the methylene cyclohexane, HBr in peroxide, we will add HBr but anti-Markovnikov, so the hydrogen will go to the carbon carrying less hydrogen, so it will be this carbon will carry the hydrogen, and this the Br. Reacting this bromo compound with magnesium in ether, form a Grignard reagent, add solid carbon dioxide to it, we get the salt. Hydrolysis furnish the target molecule. To transfer 6-bromo-3,4-dihydronaphthalene 1,2-H-on to 5-oxo 5,6,7,8 tetrahydronaphthalene 2-carboxylic acid. Again, we have here, instead of Br, we have COH. So we can use Grignard with CO2. But we have here carbon double bond O, and we have Grignard. We can't do that, right? This is wrong, because the molecule will react with itself. So what we have to do first is protecting this carbonyl in the form of acetal. Then react the Grignard with CO2. And we can get the Grignard from the bromo compound, the protected one, of course. And here is our starting material. How we do that? That's correct. Reacting with ethylene glycol in presence of acid catalyst to form acetal. Take the bromo compound, reacted with magnesium in ether, form Grignard. With CO2, you form the salt. Hydrolysis of the salt and breaking up the acetal, hydrolysis using acidified water furnish the target molecule. See you next lecture.